So let's do another example problem here. Let's consider an object here and we throw it downwards. So let's say the mass of the object is 2.1 kilograms and we throw it downwards at a velocity of 1.5 meters per second, and it goes downwards a distance of 0.75 meters, and I want to know how fast is it moving when it hits the ground. Now, this problem, we got a distance, we got initial velocity up here, we want to find the final velocity down here. We know that there's an acceleration, so we can do this from our equations before. X naught plus V naught t plus 1/2 gt squared. I'm going to say down positive. V equals V naught plus gt. We know X, we know V naught, we know 1/2, we know G. So we solve quadratic equation up here for T. Plug in here, we get two values. You got to pick one of those values, plug into the other equation, and we get the answer. This is chapter 2. You know how to do it that way. There's another way of doing this problem, though, and that is to say that as it's falling, that gravity is doing work on it. So we know that the force of gravity is going to be mg, and it's going to go this distance x. So the work done is mgx. Okay. So also know that work is the change in energy. So it had some initial kinetic energy, okay? Then we did work on it, okay? And now it has a final kinetic energy. So the 1/2 mv naught squared plus the mgx equals the 1/2 mv squared. The m's cancel. We can multiply through by 2, so v naught squared plus 2gx equals v squared, and then we take a square root. So v is the square root of v naught squared plus 2gx. So that would be equal to square root of 1.5 meter per second squared plus 2 times 9.81 meter per second squared times 0.75 meters. And so this comes out to be 4.12 meters per second. Okay. And so we have another way of solving this problem. Now, actually, I think this way of solving the problem is a little bit easier than doing it with the quadratic equation and solving there and so forth. So, so we have two ways of solving it. One, using this work energy theorem, okay, and the other way doing it the brute force method of chapter 2. Now, the brute force method does have its utilities and so forth, but I am thinking that this is another way of solving it, and this way can be applied for other problems that are much more difficult to solve using the old kinematic methods.